Before I moving to my session, I would like to give you some announcement here. And as you can remember, who participated for the first event, first meetup, we were announcing that for proposals and for some giveaways. So still, things we have received several proposals so far, and deadline is reaching 31st because we had to extend to some of the universities. Asked us to extend till end of this month since they are finally project going on until that time. So it is 31st. You can still have the chance if you want to send a proposal to send us. So you have the chance to win a latest Get board. So that is the announcement I have made. So so we are independent of selecting the winners. This is done by a panel. Two lecturers from the University of Colombo and one from University of Colombo with the first session today, and Dr. Chamat, Dr. Kasun Dilunika. So they will be selecting the winning proposals, and we are not involved in it, so we are going. Thanks. Okay, we will move to the session today, and I named it something like this because this is not something introduction to Raspberry Pi. This is something I would like to talk. What is the passion or what is the intention behind the Raspberry Pi, and now where it's going as the personal as a small computer. So but today we are seeing a nice small computer. Why is that? So this is the hardware layout. If you are familiar with Raspberry Pi, you know otherwise. And you can see this is a credit card size computer, and it has almost all the features that a computer should have, right? And I mentioned it started with a microcontroller, that means as a development board. But today it's a microcomputer. Right? The change is done by the first guy that listed here, that ECM 2835 SOC. I come to the SOCs, details about the SOCs, and we keep that here. SOC contains CPU and GPU, and then it can has a memory 256 or 512, and then all USB ports and all sort of videos and audios that almost all. Whatever you require, HDMI, all the relays, video ports and everything, and then the camera serial interface for nice, highly resolution cameras, and then ESI interface for the displays, LCDs and all. And more interestingly, set of GPUs. That means GPUs are the external, that means interface that link the external stuff into the computer. So we'll talk some of this in the next few slides, but this is almost a computer. In addition to that, it has some interfaces to the external world to deal with the hardware stuff. And when it comes to SOC, because you will see at the end of this session by emphasizing on this, because the definition of the SOC is just a small chip, and it contains all the equipments that are required for some system to work on. So typically SOC consists of a microcontroller, processor, and the memory blocks, and all other timing sources, interfaces, that is popular interfaces like internet, USB 232, likewise everything is there, and it's kind of a time computer. Why these SOCs are that much popular those days is, you know, in the 2007-8 that these mobile smartphones came into the picture. And it is kind of a computer. That is, in order to have this everything running, the videos, internet, and all the things, you need some nice hardware, and the space is very little. So, fortunately, there are several this kind of SOC developers, manufacturers, and they came across with nice set of these kind of tiny chips, and it revolutionized the world. That is the way the mobile computing and things going on. And these days, this mobile phones and the tabs have almost all the features that PCs has. So the even and the team who was developing the Raspberry Pi, and when they are developing that with the microcontroller, that is Atmega chip, they realized, okay, in order to catch up with the kids, now kids are not in the 90s, because 98 kids it's fine, DOS is fine, and that means CLI is more than enough, but these days kids will not be attracted. So we should go with some nice graphical features. So then they realized, okay, there's a nice SOC introduced by Broadcom, and then they get this thing and they move away from that microcontroller at Mega, and they embedded that into the Raspberry Pi. Then only, their main intention was to get something graphical and get something user, that means UI rich to the kids, because they thought in the era of 2000 kids will be attracted because of that. And this basically this sock has two parts. Yes, several parts. Basically, it makes that development board, Raspberry Pi initial development board, into a nice microcomputer. So, if you take about features of this SOC, basically I said it's an ARM11 processor and it's operating in 700 megahertz. And if we talk about the performance, it is 0.041 G-flops. I think you know the flops, that means floating point operation per second. So that's a benchmark for measuring the performance of the CPUs and GPUs. And it is very similar to Pentium 2 performance in 1997. Right? So it's a decent processor. In addition to that, it has the big man. It's called Broadcom VideoCore 4 GPU. And it is, look at the numbers. It is running on 25 megahertz, 250 megahertz, but it has 24 G-flops compute power. Compared to processor, the CPU, it is big. Right? And roughly, it is something similar to Xbox in 2001. So you can see how that is GUI rich this device is. So this SOC gives nice that means features into that development board to make into a nice microcomputer. So why I am talking this much about this SOC? And we will see other details about this SOC later as well. But when we talk about, we forget about the other stuff and we go to power. And actually, this is running without heatsink. Even that means even it is running in its default speed in 700 megahertz, and the power consumption is very low. There is another attraction feature of this microcomputer. And then the next, I said is a microcomputer, yes, and this is the next attractive part, because using this you can link very easily the hardware stuff to this using the GPIOs. And this is a kind of a bridge that connecting the software world and the hardware world. And it has some set of GPIO pins, nearly 70, including all the serial buses that's Mr. Lanito, SPI, UART, I2C, all these three famous buses are available there. So this is a nice landscape. If you want to bridge, that means you want your software of the hardware stuff, it's a nice landscape, and this adds some additional values to the Raspberry Pi, because it's not a simple microcomputer, and it has some bridging between electronics as well. So with these features, that is the main reason I bought Raspberry Pi. So my experience, I will tell that is, I wanted to do some IoT project, and I thought, okay, the Raspberry Pi is the most recent and available one at that time, a few months back, I think. So I thought of getting a Raspberry Pi, but I got because of the GPU features. But one day, my personal laptop was it's not working, so I wanted to watch a movie, and it is I wanted to run it in my office laptop, and it is in 12 inch. I thought it's not good to watch a movie in 12 inch, and so I thought, okay, why not give a try to Raspberry Pi? And then but I didn't have confidence. I thought, because it is a tiny guy, and if I run a full HD movie, it will burn up. Sometimes it will be, there is a crash in between because of the power, because to play a full HD movie, you need some CPU and GPU power. So I didn't know anything about this, because I only focusing about GPIO, that is my map. So then I bought buying this Raspberry Pi. So I connected with my LCD and I watched the full movie. First few minutes I was concerned, okay, whether it started or not, but then I forgot with the movie, and it played nicely. All film, it played nicely without any problem. So then I wanted to search for it, why this guy is working more than my earliest PC, because I could run a full engine movie there because it has some problems. Then I realized only I didn't know, but whole world knows this is a nice box, nice tiny computer to run a media center. It is very famous, and even though the events and events team was main intention to build a computer for the kids, it has gone up to another path, and it has taken the interest of most of the other people in this side, that the media side, making as a media player was. So why, that is my story, because why I was interested in this team. And I will tell you this story, the boot up. I know this is a little bit techy, but I wanted to tell this to convince you the GPU, the power of the GPU that Raspberry Pi has, and most of the people doesn't know and doesn't value, right? So you know the normal in the PC boot, how the computer is booting up. Same thing goes here, but a little bit different. It has a three-stage boot. First, the power on, it loads some hardwired stuff and loading the boot instructions, hardwired instruction, and the second level, most that is, you know in the PCs, the second level, the CPU takes care of other stuff. But here, not the CPU, but the GPU takes care of that. You see the details? And the second level, the GPU loads the second level instructions and process, and then the third level, CPU takes care. So, this is the first stage, and you power on, and then what it does is it loads the instruction set from the ROM chip and load the instructions required to mount the instructions, the file which contains the instruction for the second boot loading. And this instruction set was manufactured written, and you don't have this is hardwired. The next stage, but normal PCs, the CPU does the job, but here CPU and RAM both are not in the picture. Because they are still in the reset mode, RAM is not occupied. And what happens is GPU takes control. You see the numbers, how powerful GPU is. GPU takes the second boot level instructions and it loads it into cache and executes. And then it enables RAM and it does the next level thing, but still this ARM level CPU is in the CPU mode. Right? And the next level only, this GPU takes the control and it splits the RAM, and if he gets the full first memory slots of the RAM, and the next slots will be given to the CPU, and CPU is the second level citizen in this computer. And then it loads the BIOS kind of settings. It's not BIOS, it will be similar to BIOS configurations, and then loads the kernel instructions, and then after the kernel is loaded, this control is given to the CPU. Yes, this is a bit strange, but in the Raspberry Pi, not the CPU, but GPU is dominating. So that is why it took another path. Rather than going on yes, it is popular in that aspect as well, the events initial aspect, but this is more popular than that. So it has these capabilities. This GPU that is a Broadcom GPU, the video core GPU has these capabilities. It can run full HD, encoding and decoding without any problem, without any stacking. And then it has advanced ISP, and it is capable of processing images from even 20 megapixel camera. And OpenGL, and this is the TCP, and it's kind of encryption, because if you want to provide output to a screen something like this, if TCP is available, it is encrypted and everything, right? So it is capable of handling that secret mechanism as well. These GPUs are not powerful. So the new avenue has been created, and people have even written the books. Even when I'm buying Raspberry Pi, I didn't know this. And you know that XBMC, Xbox Media Technology, is named as something else. And if you have used Xbox, you have the experience, and if you not, you will see that in the next session. And Raspberry Pi is the device today that which runs most of the, uses the most of the XBMC software. Right? So another part, because of this powerful GPU. So we thought of that widening eyes, and we thought of get your interest on this thing, because Rather than talking about the GPIO and other cables, which is R3, R35, we thought of talking about this thing, and now